So here we come for the rise and fall method of our leveling operations. As you can see, I've already replicated this on a different node because obviously this space is already gone. So we will freshly sort the same thing, that we have to find out the same things basically on the diagram. So all the green color lines, whatever we have determined from the previous set. So already, since we have determined this, so let us do one thing. Let us solve the rise and fall method, and eventually we are going to verify this with these numbers or with these numbers on the diagram itself. So let's start off with the rise and fall. As you can see, as you can actually understand what is a rise and fall. Rise and fall means basically if the ground surface has gone on a rising note or has fallen on the downward note. So basically the name suggests whatever the process is basically suggested by the name itself. Rise and fall. If the ground is going upwards, it's a rise. If the ground is going downwards, it's a fall. So eventually we have to figure it out. For that we need to find out how much is the rise, which is again calculated in meters. By the way, I forgot to mention something. All these calculations are in meters, meters and meters. I have already written on the diagram, but I forgot to actually mention over here. So all these readings are recorded in meters on a general note. Fine. So this is the rise. Somewhere here I will write the fall, and as per I'll write the RLs. It remains the same trick. The RL will be written in green color just to make sure what is happening. And now whatever is falling on in the rise, it will be added to the RL. Whatever we will write on the fall will be subtracted from the RL. That's it. That's the only thing. Okay. Now to understand this, we have to look simultaneously into this as well as this. I tell my students, I tell the viewers that if you picturize a problem, 95% of the problem is already solved. You picturize this thing, 95%. See, whatever data we have done, we have equally picturized as well as plotted. If you only have this data and no picturization, everything will be seeming like a formulation, a mug-up thing, and that's it. No creativity. And if you just have this, you do not have the data. You have the data, but you do not have the table. Still, you can figure out the data from here. Actually, whatever we had done in the previous numerical, the explanation of this. So you picturize this, 95% of the thing is sorted. The remaining 5% will be done by a calculator and your intuition. So that is how we must proceed. Always picturize any problem, whatever be the problem, not just solving any problem, any engineering problem whatsoever. Picturize it. You can literally solve half, rather more than half the thing. Anyway, so philosophy is on another note. Let's come back to the discussion. Let's come back to the solution. Rise and fall. So at station 1, we know something whatever is at station 1. You can see that at station 1 we already know what is the RL, right? These are all calculated ones, mind you. Do not get confused. If you are seeing this video for the very first time, I would suggest you to previously or to actually watch the immediately previous video or the previous to previous one, because when we have started this series, we only had this. We never had this. These are all calculated values as we have calculated over here. This was the only value which we knew. This was the only value which we knew. So going by this is the only value which we know. Let me just draw it for you. There you go. It is 100 meters. Now, why did not I write any rise and fall in this first line? Because standing over here, how can you say that if you have risen or fallen? You have to go to a second point to judge that yes, I have gone downwards, I have gone upwards. So it is only at the second point of reference where you can figure out if you have gone upwards or if you have gone downwards. So that is why the rise and fall should always be mentioned from the second sentence or second line. So now you go to the second station and then you figure it out. If you have risen or fallen. This diagram over here, as per this diagram, you can see that you have gone actually downhill. That means you have fallen. But if you do not have the diagram, then how will you understand just by this? This can be understood by the nature of this. If the readings increase, then you are actually falling. If the readings decrease, for example this, you are actually rising. Now you do not believe me, believe the picture. Readings are increasing, you are falling. Readings are decreasing, you are rising. So if just you won't have this often, but you will always have this. If you want to read it out from the just from the data table itself, this is the only procedure which you will have to read it through. Readings are increasing, that means you are going downwards. Readings are increasing, that decreasing, that means you are going upwards. As simple as that. Get it straight inside your head. So since you can see that the readings have increased, that means there has been a fall. So I must not write anything under the rise. I must always write in some things on the fall. So what is the fall which you have? The difference between this reading. That's it. So how much is the difference between this reading? It is actually 3 minus 2 is equal to 1 meter. Now anybody can say, okay, no, it is actually 2 minus 3, right? Now for this confusion, so that it is not getting confused, this is always negative and this is always positive. I told you, whenever you are going to actually find out the RL using this method, you have to either go for the rise and go for the fall. If the fall is happening, I'm sorry, then whatever value you have minus whatever value you get over here. Okay, always the difference, the modulus of the difference, you can call it. So basically you have 1 meter and that is under the negative. So the new RL will be how much? It's the previous RL minus or plus. If it was a rise, then it would have been plus. Since it's fall, it is minus. So it is how much? 99 meters. Isn't it the same thing as over here? And isn't it the same thing which we have written over here? This is written because we have calculated it from the previous. So this is 99 meters and again this is 99 meters. I think I have made my discussion clear. That is how you actually find out the RL using rise and fall. Let's see the next big thing. Let's test it out. So we are going to test out for the station number 3. Mind you, do not look at the figures because these are nothing but solutions which are already sorted while we have actually discussed this method. So to understand how this came, you either look into this or you ignore the green color portion on the diagram. You slowly, along with me, please proceed forward. It will be helpful for you. Now you see that the reading has, from station number 2 till station number 3, the reading has actually got short. The reading has reduced. As I said before, if the reading reduces, that means the ground is increasing. Sorry. That means the ground is basically increasing. And as you can see from here also, the ground is increasing. So basically you're rising. So whatever difference happens in between, it will fall under the rise. So how much is the difference? It is nothing but 3 minus 1, which is equal to 2 meter. And I told you that this is whatever value you have over here should be added with the previous RL. So what is the new RL of this point? You have the previous RL 99 plus 2, which is equal to 101. Cross check, it is still 101. So we are actually heading in the right direction. Next one is basically the most controversial one, this 0.3 and 0.4. Now how do you actually figure out the 0.3 and 0.4 one? Now you see that at 0.3 you already knew the RL from this previous set of data, right? You knew the RL from the previous set of data, right? So already this RL is known. Already you have known it. Now you have to go from here to here. Now when you are coming to the next set of data, you are basically taking this data. This is the first data for the new setup This is the second data for the new setup, etc. So what is the first data called? It is always called as backside. So the backside, and the next data is basically foresight. I'm sorry, intermediate side, and the last data is known as the foresight. So whatever will be the difference on this direction, whatever will be the difference on this direction will be added or subtracted as per from the previous RL. So what is the difference over here? It's 5 minus 4. Can you see? So it's basically 5 minus 4. So, and it is actually, the reading is actually going down. Reading is reducing. So the ground is increasing. Absolutely, yes. So we are basically rising. And how much did you rise? It's very, very simple. It's 5 minus 4, which is 1 meter. And as per what will be the RL? You can see the previous RL plus. Why plus? Because it is actually the rise value which we are taking. Plus 1, which is how much? 102 meter. Yes, my dear, we are right on the track. At 4, station 4, we have 102 meters. At 4, we are still having 102 meters. So we are actually going in the right direction. So I think most of you have already figured these things out, started to figure these things out. Again, the readings from here. Now we are considering the station number 5. So from 4 to 5, you can see that the reading is basically decreasing. That means the ground is increasing. We are actually rising. And make no mistake, from 4 to 5, the ground is actually increasing. Rising rather. So what is the, how much is the rise? The difference between the side readings. And how much is the difference? 4 minus 2, which is 2 meter. So what will be the RL of this point? It's again the same formulation. Previous RL plus or minus the rise or fall. If it is rise, it is plus. If it's fall, it's minus. How much is it? 104 meter. Cross verify it over here. And the last one is from 5 to 6. From 5 to 6. As you can see on the diagram itself, from 5 to 6, we are again having a short of reading. I mean the reading is basically getting short. Means the ground is again rising. How much it was the difference in over here? 1 meter. So the ground has risen by 1 meter. So if the ground has risen by 1 meter, that means the RL of this place plus 1 meter will be the RL of this place. RL of the previous station plus the difference will be basically RL. 104 plus 1 is 105. And how did you get that difference? Right over here. 2 minus 1 is equal to 1 meter. And then you have the final reading, which is 104 plus 1 is 105 meter. Case is closed. What you have to do is, there is one check which you need to do, is basically the sum of RLs minus, sorry, the sum of rise minus the sum of fall. You have to calculate, as simple as that. Summation of fall we have to calculate over here. So there is, how much is the sum of this? It's 2 meter plus 1 meter, 3 plus 2, 5 plus 1, 6. It is 6. And how much is the summation of fall? It is nothing but 1. So the check lies, there is a check, small check, that you have done it correctly. Now, if not every time you are going to compare with this, right? So you have to do this again and again, you have to do this and then to compare. It's a very, very hectic task and it's an absurd task again. So how do you actually check it? You check it by a small thing. Backside summation. Oh yes, by the way, there is another summation which you need to do over here. This is one, this is one. Summation of BS is how much? 2 plus 5 is 7. Summation of foresight is how much? 1 plus 1 is 2. So summation of backside minus summation of foresight will be equal to the summation of rise minus summation of fall, will be equal to last RL minus first RL. How much is the summation of this minus this? 5. 7 minus 2 is 5. This one is 5. How much is summation of rise minus summation of fall? 6 minus 1. Again it is 5. And how much is the last hurdle minus first hurdle? 105 minus 100. So again it is 5. So if these three values are actually matching, you have successfully completed solving this thing. So I hope I made myself clear to everybody, whoever is taking the help of this video. So this is how you actually calculate the RL of different positions using the height of instrument method and the rise and fall method simultaneously. So with this, I end my discussion over here. Thank you for actually listening to this. Thank you so much. If this procedure, if this thing is actually helpful, I will be ever grateful to all of you, whoever finds this video fruitful enough. With this, I end my discussion for today. Have a nice time ahead, everybody.